Rust provides a loop keyword that indicates an infinite loop. Oh, wait a second. Infinite loop. That's like we've heard in computer science that infinite loops are problematic because that's when a computer will just get stuck in a repeating cycle that never ends. While it is dangerous, it is very powerful. This is one of the most common capabilities and most powerful opportunities you have with computers. They have the capability of repeating a process over and over and over very quickly. And if you throw some advanced logic in there, they become even more powerful. There's ways to escape the infinite loop, and they are pretty much mandatory for most scenarios. I guess all scenarios, right? There's got to be an exit point. There has to be an exit point. If you're a game developer, you're going to be building a game loop, and that loop will render frames as fast as possible, and it needs to keep doing that over and over and over. The exit point would be either leaving that game loop to enter like a menu loop, so a different game loop, or exiting the program altogether. So you have to have exit points. And there are some opportunities here. The break statement will let you do that. It says, okay, we're going to break the infinite loop. It's used to exit the loop at any time. There's also a continue statement, which is great because you can hit a point in your code where you want to jump back up to the top of the loop. So you don't need to continue down. You want to continue up. So we're going to define a mutable variable called count. This will be our counter. It's going to be initialized to 0. I would like it if they, put some underlines here to let us know. Remember, in Rust, you can say what the literal data type is. You can also have underscores, which represent nothing. It's just a way to improve readability. So now we're going to create an infinite loop. Uh-oh, danger zone. We better make sure we have an exit point. So you start the loop, you increment the counter, so plus equals 1. So it starts at 0. So the first time we enter the loop, this first line is going to increment the count variable to 1. Now we're going to check to see if the count is 3. So it won't be 3 initially, but when it is, we're going to print that it's 3. And then we're going to skip the rest of the code. However, it's 1 right now, so it's going to continue down. It's going to print out the current count, and then it's going to check if the count is 5. And if it's 5, this is our exit point. So we're going to we're going to run this code, and it says, okay, so we're creating the infinite loop. We print out our counter, then we continue. Basically, neither of these if statements are triggered yet. So we do that a few more times. Then 3, because we hit this one, we hit this if statement, and then instead of printing the number itself, we just print the word. Then we continue skipping the rest of the loop. Now it's 4, and then it hits 5, and then we exit. We've made it to the exit point. We have to be careful. I wonder if Rust will even let you do this. Will the compiler let you compile an infinite loop that doesn't break? Well, let's try it again. So what's happening here is it's executing the infinite loop, and the server that's letting us run and execute and build this code is saying you did something really bad, and it just discontinues. So it looks like the compiler will let you build this code and run it, though now you're just going to have a piece of code that works. It works perfectly fine. It's just going to be stuck doing an increment on a counter. This is weird. I thought we were done with these kinds of labels and skipping. This is kind of something that you see very often in assembly and C as well with these go-to statements. So here we have, for example, taking a look at their labeling of different addresses of the code statements. We have these go-to start, which is a start label here, and then it will begin executing these instructions. And then we have a reset label as well, so you could say go to reset. And I didn't know that Rust was going to bring along these kinds of... There is a good reason, although I'm wondering if there's a better approach. For example, if you are doing nested looping, you want to be able to break out of both loops at the same time. You can do a double break or triple break, depending on how many nested items you have. In this case, we have 2 loops. We have the outer loop and an inner loop. You can also continue outer loops? Oh, no way. That's really cool. Okay, so we've got 2 infinite loops here. So danger zone, right? We want to be able to, we have to break both of them. So at some point we want to break. And what you can do is you can break and you can pass a label to say, I want to break the outer loop, which will break all the loops in this case. We will have the exit point. So an inner loop can break. That's really cool. You can also say continue, and that will continue the outer loop. which is exactly the same as this. These two statements will be identical. And also, if you wanted, these three statements will do the exact same thing. It says continue the outer, which will start here again. This says break, which is going to break. Wait, no, I was wrong. Break is going to continue onward to here. It's going to break this loop and move over here. So this point will be reached if you have this in this case. And if you break this inner loop, it will do the same thing here. Okay, so we actually have two separate items here. This will break the inner loop. This will continue to the outer loop, jumping immediately here. So you've got some options on where you want your loop flow control to be done. You can direct it a lot easier with this. All right, we're going to start with the default and we're going to give it a try. We're going to see what this runs as. Let's see what is. All right, so we've got entered the outer loop, entered the inner loop, exited the outer loop. So we start here. The main immediately goes into the inner loop, and then we go to the even further loop again. So we go first loop, second loop, and then we break the outer loop, which takes everything down to the exit point. And so this code is never reached. And one of the Rust things I don't know if the compiler would ever be able to detect this. One of the common things Rust will let you do with the compiler will say, hey, there is some code that will never be reached. That might be a Clippy thing where you can Clippy check your program and it will give you some recommendations. If we break this loop, this point will be reached. So let's try to see what that looks like. What's the compiler going to do? The compiler is unhappy about this because the outer loop is infinitely looping because we've never broken it. But if we put a break here, then we reach the point that is unreachable with right here. This point will never be reached, but it was because we broke here and then we broke again, which allowed us to break out of the final loop and we made it to the exit point. I think there are better patterns overall. I don't think we need to use these labels and breaks because it's a lot of jumping around. I feel like there's a cleaner way to go about building this code, and it is a little confusing as well. Even though it's fairly clean and there's not that much code here, I don't like this level of nesting is just a bit much. I kind of don't like to nest that much in general. Keep things clean and simple. Rust is doing it again. Look, it's doing a thing. I can't believe. Look, you can assign a variable to a loop. Isn't that what's going on? I really, really like this pattern. It is very powerful. It allows you to go into a block of code, execute some logic in a loop pattern till you've come up with your calculated solution. And then you can assign the output into a variable. You can use the loop. This loop block right here can be captured. You can capture the data. Anything that any sort of the break becomes sort of like the return statement in this case. You can break the data. I don't think this semicolon is needed. I think you can exclude it. Let's find out. That's right. Okay. No, yep, that works. I do like to see some. Let's double check this. Print ln exclamation point counter. So counter's 10. Oh, wait, hold on. Okay. And then we want to print out the result as well. So counter is 10. And the result is double because the result has been, there we go. This is really cool. I've used this pattern in production code. It is really powerful. Of course, danger zone. You want to make sure that there's always a guaranteed break. So the code can always make it. So you might want to have an exit condition if the counter exceeds a certain level. And maybe you return data that indicates that there are too many iterations. So you always want to make sure this is a danger zone here. However, it's really powerful. I really like this approach. And you know what? Not many languages let you do this kind of thing. They just haven't built up to it. It's really powerful. It's also very efficient running on the stack memory. If you get a chance, use this pattern. It's clean, it's easy. Because infinite loops are so dangerous because they can cause a program to get stuck permanently forever into infinity, there is a very common keyword in most, if not all languages in a loop called a while. This while keyword lets you define basically, it's the same as an infinite loop, except that it gives you a criteria of condition for exit. When will the loop stop? And because you always need that protection, a while loop tends to be more common than just a regular infinite loop, right? This kind of loop right here is your infinite loop. It will loop forever unless you have some code to exit, where the while loop always requires you to have that exit condition built in, and that's necessary. While loop is going to be safer, and you will tend to see those more. So the while keyword can be used to run a loop while a condition is true. So we've got a number here, which is our counter, and we're going to loop until this number is over 102 in this case, right? Because if this was 102, then this statement is false. Oh, but also if it's 101, then the statement is also false because they're equal to each other. So as soon as the number becomes 101, the loop will break. So loop while the number is less than 101. And then we can increment here. Well, okay, so let's talk about that for real second. The while loop, it does have an exit condition built into the syntax for this keyword. However, unless this number is modified or the condition can be evaluated as an exit point, for example, if we comment this out, there's still a danger. This while loop can still be an infinite loop. It is nicer here that we do see the exit condition immediately built in. So there is just a little bit of an improvement. It's a little bit nicer than your standard loop. All right, let's see what happens when we run this application really quick. Okay, so we've got a whole bunch. This is what you'll see when you're running a program with a loop. You'll get a lot of output. So it looks like it's checking to see if it's divisible by 15, if it's divisible by 3, divisible by 5, or any other. So, okay, so if it's divisible by 3, instead of printing 3, it's going to print fizz, buzz for 5, fizz again, and then fizz for 9. So 6, 9, buzz is 10, and then 15 is going to be fizz buzz. Pretty good example. I think this is okay. Just be careful. You'll definitely want to make sure to have your exit condition to be evaluated to an exit point. And as a bonus, I think you can also do a variable binding like this. Print ln v. So whatever the number ends up being, which will be great, it should be 101, right? Or, yeah, 101. Or, yeah, let's see. It should be 101. Okay, I ran into an issue. This is an issue. It's important to know. The compiler won't let us do this pattern. You can do it with a loop, but not a while loop. Apparently, you cannot break with a value inside of a while loop. Interesting. Okay. You can only break a value inside of a loop or a breakable block. Okay. So, in this case, this pattern doesn't work. But if it's a loop, it'll work. But if it's a while loop, it doesn't work. It doesn't seem like it's that far off from being able to do something like that. But hey, there we go. At least we know. If we want to be able to get the value, any data within inside this while loop, we want to turn it into a loop and just change up the pattern just a little bit. So we do that like this, loop, and then we say if. All right, here we go. So we just changed it from a while loop into a regular loop, and then we updated the condition here so that way it matches a break condition, and then we can return the value from the loop, assigning it to v. At the very bottom, it should be 101. I guess that's fine. We could even make it a little bit easier to read by putting the break condition up top. So now it's basically the same, though now we can capture the data within the loop. Why wouldn't they let you do that with while loops?